Lesson 21, I will solve division problems with remainders using the area model. So lesson 20 was about dividing using the area model, but if you noticed in all of those problems, none of them had a remainder. Today we're going to extend our use of the area model with problems that have a remainder. Okay, so in your math journal, I want you to go ahead and get it ready today, write today's date, and be sure that you label it division using area model with remainders. Now, the first thing I want you to do, I don't want you to draw this in your math journal. I just want you to look at it with me for a second. You'll notice that this rectangle has a side length of 18. I'm going to make this just a little bit bigger so that we can see it a little bit better. So you can see that this rectangle has an area of 36 square units. It has a length of 18 and a length of 2. So if I go up 1 from 18 to 19, what would happen to the area? What would be the area of this rectangle? If you did 19 times 2, you would find that the area of this rectangle is 38 square units. So I went from 37 to 38, but I went from 18 to 19. So how would I show a rectangle that has an area of 37 square units? It wouldn't be a length of 18 and it wouldn't be a length of 19. And the reason is because there would actually be a remainder, and that's what we're going to talk about today. So I do want you to draw this in your math journal. Go ahead and draw a rectangle and label the width of it 2. And I also want you to find room to do 37 divided by 2 because we're also going to use long division or standard algorithm along with this. All right, so we already talked about that we cannot represent a rectangle with an area of 37 because we're going to have a remainder. So here's what we're going to do. We're going to approach this a little bit differently than we did yesterday. Yesterday I just kind of thought of 37 and I thought of how could I divide 37 by 2 and I just picked something. Today we're going to use a little bit more of a long division approach. And we're going to say, okay, well there's 3 tens. How many times does 2 go into 3? And 2 goes into 3 once. So you're going to label this rectangle 110. And then inside of it, I want you to put 20 square units. Because 110 times 2 is 20. So if you notice, then we're going to go ahead and continue our long division. 1 times 2 is 2, and that would leave a remainder of 110 and 7 ones, which would look like this. Okay? So now we're going to think to ourselves, how many times does 2 go into 17? Just like we do when we do long division. So I'm thinking, well, 6 times 2 is 12, 7 times 2 is 14, 8 times 2 is 16, but 9 times 2 is 18. So I can't do 9, so I'm going to have to go back to 8. Okay? So what I want you to do now is we're going to extend our rectangle like this. And I want you to label the length 8. And this will be 8 ones, so you can just put 8. Oops, that's a little big, isn't it? Let's do 8 ones. And now what would be the area of this rectangle? We have 8 by 2, so it would be 16, right? So we're going to put an area of 16 square units. So now I have 110, 8 ones, 20 square units, 16 square units. Go ahead and continue your long division. 8 times 2 is 16, so now I have a remainder of 1. 2 does not go into 1 anytime. So the way that you show that is you're going to put a remaining square on the end like this, and inside of it you're going to put a 1, show that you have a remainder of 1. So 37 divided by 2 would be 110 and 8 ones, which is 18, remainder 1. So if we want to look at this using the distributive property like we were using with the area model before, we could say 20, like this right here, 20 divided by 2 is 10, 16 divided by 8 is 2, and then 10 plus 8 equals 18, right? But we have a remainder of 1. So if I wanted to check my work, 18 times 2 would be 36. 36 plus 1 equals 37. So I know that my answer is correct. We're going to do one more problem just like this in your math journal. I know that was pretty quick, but I think you'll get the hang of it if you just keep with me and follow along. All right, so this time we're going to do 76 divided by 3. So what would the total area be of the rectangle? It would be 76 square units, right? So we're going to try to take 76 and divide it by 3. So I want you to draw this rectangle and label the side with 3. Then I want you to make a space for you to be able to do the long division, 76 divided by 3 over here. All right, so I have 7 tens, and I want to figure out how many tens, how many times does 3 go into 7/10? So 3 times 3 is 9, that's too much, so it'd be 2. So let's label the width up here 2 tens. Okay, so we're going to do 2 tens. Let's see, I'm going to go to the next slide. Oops. All right, so if I put 2 tens up here, get ready. All right, 2 tens. So the area of this rectangle would be 60 square units. And then with my long division, that would look like this. 76 divided by 3, and there's my 2 tens. 2 times 3 is 6, and that's going to leave 1 10 left over. But then when I add my ones to that, now I've got 16. Okay, so I've got 16 here. Okay, so now I'm thinking to myself, how many 3's are in 16? So I know 5 times 3 is 15. So I'm going to extend my rectangle. And I'm going to go ahead and label this. Let's go back up here and let's label this. So this would be 2 tens. So let's go ahead and write this as 2 tens. And I know that I can do 5 ones. And the area of this rectangle would be 15 square units. So I would come over here and I would say 5 times 3 is 15. And that would leave me with a remainder of 1. So I'll just go ahead and add my small rectangle here and have a remainder of 1. So I have 25. 76 divided by 3 is 25, remainder 1. So let's go ahead and finish and see here. Okay, so we did that. All right, now we can go ahead and we could check if we wanted to. If we want to go ahead and use our distributive property, we could say that right up here we had 60 divided by 3 here, and we added that to 15 divided by 3. And then we put this in parentheses. That just means that you're going to divide before you add. And 60 divided by 3 would be 20. Plus 15 divided by 3 would be 5. And that would equal 25. And then I'd have to add my remainder 1. So 25, remainder 1. All right, let's go ahead and get our problem set. Go ahead and put your name on there. And we're going to work through some of these together. I know that it may still be a little bit confusing to you right now, but don't fret. I promise you that it will get better as we go along. All right, so we're going to solve 37 divided by 2 using an area model, use long division and the distributive property to record your work. So we're going to start with a rectangle. I'm going to cheat a little bit so it's nice and neat. And then the area here is 37, and I'm divided by 2, so that means that the width of my rectangle is going to be 2. And then over here I'm going to record this using long division. So I've got 37 divided by 2. So I'm thinking, how many times does 2 go into 3? So that would be 1 10, and I'm going to just divide this like this instead of adding to it. So 1 10 times 2, this would be an area of 20 square units, and that would look like this in my long division, 1 times 2, so I subtract 2. That leaves me with 110 and 7 ones, which is 17. So how many times does 2 go into 17? Well, 8 times 2 is 16, so I'm going to put 8 ones. I believe we already did this problem, didn't we? So 8 ones times 2 gives me 16 square units. So that would look like this. 8 times 2 is 16, and that's going to leave me with a remainder of 1. So I'm going to come over here and put my remainder 1. So I use an area model. I use long division. Now I have to use a distributive property. So I'm going to come over here. 20 divided by 2 plus 16 divided by 2. So 20 divided by 2 is 10, plus 16 divided by 2 is 8. 10 plus 8 is 18, and then I had a remainder of 1. All right, so let's go on to number 2. Now it says solve 76 divided by 3 using the area model. Again, I believe we just did this together as well. Use long division and the distributive property to record your work. All right, so we're going to go ahead and start with a rectangle that looks like this. And my width is 3, excuse me, my width is 3, and then over here I'm going to use long division, 76 divided by 3. So I have 7 tens, and I know that 3 will go into 7 2 times. So this would be 2 tens, just like this. So 2 tens times 3 would be 60 square units. So 2 times 3 would be 6. That would leave me with 1 10 and 6 ones, which is 16. So 3 will go into 16 5 times. So this would be 5 ones, and that would make the area of this rectangle 15 square units. And then 5 times 3 is 15. That's going to leave a remainder of 1. So now using the distributive property, I have 20 divided by, nope, that should be 60. 60 divided by 3 plus 15 divided by 3. 60 divided by 3 is 20, plus 15 divided by 3 is 5. 20 plus 5 is 25, and then I have a remainder of 1. I forgot to add my remainder, didn't I? A remainder of 1. Okay? All right, let's take a look at problem number 3. Carolina solved the following division problem by drawing an area model. What division problem did she solve? Take a look at that area model and see if you can figure out what division problem she solved. And then after you think you figured it out, come back and see if you got it right. All right, so the first thing I did was I had to look at the area of this rectangle. And I've got 40, and then I have 12, so that would be 52. But I see she has a remainder of 1, so that would actually be 53. So I've got 53 divided by 4. That would be the problem that Caroline solved. It says show how Caroline's model can be represented using the distributive property. So you could have written it up here, but I'm going to go ahead and write it down here. I've got a little bit more room. So she took 40 and divided it by 4, and then you would add that to 12 divided by 4. So 40 divided by 4 is 10, plus 12 divided by 4, which is 3, and that would be 13, and we had a remainder of 1. All right, solve the following problems using the area model. Support the area model with long division or the distributive property. Okay, so we're going to start with an area model. I'm going to go ahead and draw my rectangle right here. See if you can try to do this one by yourself. If you get stuck, you can always come back. You don't have to do the whole thing by yourself. You can try to just do some of it. Now, it says that I can use a distributive property or long division. I'm going to do both just in case but you can decide to do one or the other. All right, so I'm going to do 48 divided by 3. All right, so my width is 3 here. So I've got 4 tens divided by 3. So I could only put 1 10 in there. All right, so that would give me 30 square units. I'm going to come over here and put a 1 minus 3, and that's going to leave me with 1 plus 110 plus my 8 ones, which is 18. And let's see, 5, nope, 6. So I've got 6 ones. 6 ones will go times 3 is exactly 18, so it would not have a remainder this time. So this would be 6. 6 times 3 is 18. I would have no remainder. So you could stop here, but I'm going to go ahead and show this with the distributive property also. So I have 30 divided by 3 plus 18 divided by 3. So that would be 10 plus 6, which is 16. All right, 49 divided by 3. Again, if you feel comfortable, like you can do this by yourself, I'd like for you to go ahead and try. If you're not comfortable yet, you can continue to follow along with me until you do feel comfortable. All right, so I'm going to make a width of 3, and I'm going to go ahead and put my long division over here. 49 divided by 3. So 3 would go into 4 tens once. So that means that this would be 110. 110 times 3 would be 30 square units. Divide that like that. So that would leave 110 and 9 ones. So I'm thinking 6 times 3 is 18. So this would be 6 ones. That would give me 18 square, oops, put the abbreviation in the wrong spot, didn't I? Oops. Try again. I'm going to just put SU for square units. Okay, so this would be 6. 6 times 3 is 18. That would leave me with a remainder of 1. Again, you could stop here because it says long division or distributive property, but I'm going to go ahead and do both. Okay, so I've got 30 divided by 3 plus 18 divided by 3. That's 10 plus 6, which is 16, and then I had a remainder of 1. All right, so I'm going to do 56 divided by 4. You feel like you can do this by yourself? Go ahead and pause the video and try it, and then come back and see how you did. All right, so I'm trying to think of how many times 4 would go into 5, and I know that that would be 1. So this would be 110, which would give this rectangle an area of 40 square units. So when I take away the 40, that's going to leave 110 and 6 ones, and 4 will go into 16 exactly 4 times. That would give me 16 square units. That means that I would have a remainder of 0. All right, so using the distributive property, that would be 40 divided by 4 plus 16 divided by 4, which is 10 plus 4, which is 14. Now let's try 58 divided by 4. Again, if you haven't attempted to do any of these by yourself, I want you to try to do at least part of this one by yourself. If you get stuck, you can always come back and listen to the explanation, but pause the video and try to do some of it by yourself. All right, so I've got 4 would go into 5 tens one time. So that would be 110, and that would give this rectangle an area of 40 square units. So when I subtract 40, that would leave 110 and 8 ones. So that would go into 18 4 times, because 4 ones times 4 is 16. So if I put my 4 here, that's going to leave a remainder of 2. I keep forgetting to go back and put my remainder on my area model. All right, so that would be 2. I noticed I forgot to do that up there, didn't I? All right, so now I've got 40 divided by 4 plus 16 divided by 4. That would give me 10 plus 4, which is 14, and I had a remainder of 2. All right, almost finished here. So we've got 60 divided by 5. Again, try to do this by yourself, and then just come back and check with me. So I've got 66 divided by 5, so that would go into 60 one time, so that gives me an area of 50 square units, and then that would leave 110 and 6 ones, so that would go into 16 3 times, because 3 times 5 is 15, and that's going to leave me a remainder of 1. Using the distributive property, I have 50 divided by 5 plus 15 divided by 5. That would be 10 plus 3, which is 13, with a remainder of 1. Okay, so I've got 79 divided by 3. Make my width 3, and I have 79 divided by 3. So that would go into 7 2 times. So this would be 2 tens, which would give me a width of, an area of 60 square units. When I subtract 60, that leaves 19. So 6 times 3 is 18, so I'm pretty sure that's as close as I'm going to get. That will give this an area of 18 square units. That's going to leave me with a remainder of 1. Using the distributive property, 60 divided by 3 plus 18 divided by 3. This would be 20 plus 6, which is 26, and I had a remainder of 1. All right, last problem. 73 students are divided into groups of 6 students each. How many groups of 6 students are there? How many students will not be in a group of 6? So I just read it. Now I'm ready to draw something. So since we're using the area model, I'm going to go ahead and use that model to illustrate here. And I'm also going to, at the same time, go ahead and write my number sentence, which we have 73, and we are dividing it into 6. It says right here, divide it into groups of 6. So I'm going to have a width of 6, and 6 will go into 7 tens one time. So this would have a length of 110, which would give this rectangle an area of 60 square units. So when I subtract 60, that's going to leave 13. So 6 will go into 13 two times. So this would be 2 ones, which would give this an area of 12 square units. And then when I subtract 12, that leaves me with the remainder of 1. So here is my draw, and here is where I wrote my number sentence. Now I've got to write this as a statement. How many groups of 6 students are there? Well, there would be 12 groups of 6 students. So I'm going to type that. I'm going to say, there will be 12 of 6 students. Then it said how many students will not be in a group of 6. Capitalized. There will be 1 student not in a group. Okay, so that's my final W, writing it as a statement.